Okay, so hello everyone, welcome to Master the Codes, and today we are going to solve another problem for the Amazon week, that is LCA of 3 nodes. So in this particular question, what we are given a binary tree of n nodes where the nodes have integer values and 3 integers n1, n2 and n3. Okay, find the LCA, or the lowest common ancestor of the 3 nodes represented by the given 3 integer values in the binary tree. Okay, so for the LCA nodes, you can see 7, 8 and 10. The LCA is 1. Okay, so now let me give you a detailed explanation of the following. In this particular question, let's say I am given these nodes 6, 7 and 5. Now I want to evaluate the ancestor, or the least common ancestor, that is the parent of, or rather ancestor of 5, 6 and 7. Okay, so clearly you can see the LCA of n1, n2 and n3 is 2, because 2 is a direct parent of 5, 2 is an indirect parent of 7 and an indirect parent of 6. So what is an LCA? LCA is the first node that is recursive parent of the two given nodes. In simple questions, we are asked what is an LCA of 2 nodes. We are given 2 nodes, but in this time we are given 3 nodes. So in that case, we need to approach it in a different way. Now what I can do, find parent for each successive node as the parent array. A similar approach that you have used in burning the tree. If you have not checked out that video, you can check it out using the link in the description down below. I have provided for the same. So create a parent array. In this parent array, you will assign values for each children to its corresponding parent, because you know from root we can go to the children, but from children we cannot go to the root. In a tree, in graph, it is possible both ways. So clearly the value of the parent of 1 is -1, parent of 2 becomes 1, parent of 3 is also 1, and so on and so forth. You can generate the entire array, right? Now for each node, what we need to do, we need to create a boolean array to mark the parents of node n1, n2 and n3. Now what do I mean by this is, in node 1 I'll just put 3 values, or you can say a bit mask, can use a bit mask as well, like 0 0 0. Okay, and similarly you can give 0 0 0 over here, 0 0 0 over here. So what I mean to say, in the node class, when you're creating the parent, in node you have a value of, let's say, data, and then you have a left and a right. So all you need to do is you need to create an, you can say, a boolean variable, a boolean array, and that will work. So each node stores whether the current node is an ancestor of node 1, n2 or n3. Right, we'll start from the bottom. We'll first reach the leaf nodes, and then we will start recursively approaching, right? So what I want to say is, when you have reached node 6 and 7, you'll go to node 5. Okay, now if you look at this is my n2, the node that I want to evaluate the parent of. Okay, so and here it is my n1. Let's look at the case of n1. Since I have encountered 4, I'll mark this particular case as true, right? And since this is true, I'll mark the second node, or the ancestor or the parent, as well true, and similarly this will be marked true as well. And after 1, since it does not have a parent, it has only a -1, I'll backtrack, or I'll terminate the recursion. So yeah, so that is how you will do. Now if you look at this particular node, right, now what I wanted to say is, these values false, false and false represent the nodes. Like if you look at this particular node 4, it is parent of only n1, or it is the node n1 itself. So I'll mark only this particular case as true. Okay, now if you look at this particular node 5, it is a parent of both 6 and 7. So I'll mark both 6 and 7 as true. Now if you look at this particular case, if I have found any node that has all the three values as true, I'll terminate my condition. That means I would have found my LCA. Now if you look at this, in node 6, the first index is true. Similarly, this particular index will be true. And then this particular index will be true. And so on and so forth. But if you see over here, this is also true. Why this is true? Because it has followed from this particular branch. So if you just look at this particular case, I can clearly say up till now it is a ancestor of node n1 and node n2. Now, if you look at node 7, I have the second index true, and similarly I'll mark the second indexes of the upper nodes as well. And at this particular point of time, when I first found the value as true for all the three indices, I'll simply end the condition and print the LCA. So that is how you will print the LCA, and you will use the post order DFS to solve this particular question. That is all for today. I will provide the link of the question and the solution in the description down below. I have created the playlist as well for all of you to watch and learn and practice interview questions that are asked in Amazon and other companies. So please do not forget to like, share and subscribe to the channel and hit the bell icon for more notifications. Until then, see you soon in the next video.